We've seen a context in which this constant proportional behavior is going to pop up, and so that gives rise to this definition of an exponential function. And so we need to maybe develop some more understanding about what an exponential function is. Here's the definition. So we have b a positive real number. Okay, I can't stress that enough. We have to have b as a positive number, and it has to be different from 1. Okay, so when we work with b, that means b has to be greater than 0, and b cannot be 1. Otherwise, it's just going to be a boring function. Okay, but then if we have any real number x, the exponential function of base b is of the form that. And so this b we call the base, and then x, notice our exponent has that variable of x. Okay, so when we talk about exponential functions, things that are exponential functions are like y is equal to 2 to the x, y is equal to 51 to the x. We could even have fractions like 1/3 to the x. We could have y is equal to 1 over 100,000 x. Okay, all to the x. And the variable on the exponent can be something really wonky. It could be like 2 to the power of 2x minus 3. That's fine too. Things that are not exponential functions. So clearly we said we can't have 1 to the x, okay? That's kind of actually boring. It's just 1 a multiple times, so it's just 1. We also can't have, 0 to the x, okay? And then y is equal to -1 to the x. This is actually really hard to understand because we're taking -1 multiplying it by itself x times, so we don't do negatives. And then the other thing that students often get confused with is if we have something like 2 times x to the 3, like that, okay? This, my friends, is not exponential, right? It has an exponent, yes, but with exponential functions, the variable must be in the exponent. So notice that the exponent here is a constant, okay? So this is not a polynomial, or not an exponential function. That's actually a polynomial function. That's a cubic function, right? We've studied those. So that's boring. Let's move on to something new. Okay, as we look at exponential functions, so both of these are exponential functions, and we kind of mentioned them above. Let's just kind of look at them and see what happens. And so I'm just going to investigate these using a table of values. So I'm going to do x, I'm going to do y, and I'm going to say 0, 1, 2, and I also like to do -1, -2, -1, -2 as well, and just kind of see what we get out. So if I do that, 2 to the 0 power. Okay, we have to remember our properties of exponents. Anything to the 0 power is defined as 1. And then we have, 2 to the first is 2, 2 to the second is 4. Okay, what about 2 to the minus 1? 2 to the minus 1. Well, I remember if I have a negative exponent in the numerator, that's a positive exponent in the denominator, so this is just 1/2. In the same way, if I have 2 to the -2, that's 1 over 2 squared, which is 1 over 4, okay? And also it's kind of interesting. I notice that as I'm going in my table, I'm multiplying by 2 as I go down in numbers. So, and 1/2 times 1, or 1/2 times 2 would be 1. 1/4 times 2 is 1/2, okay? So, oh, that's interesting. So that multiplication by 2, which is the base, is showing up. Huh, okay. And similarly, if you go backwards in the table, okay, you're dividing by 2. So that's another thing that you can be on the lookout for is in exponential functions. As you increase x, you're multiplying by whatever b is. As you decrease x, you're dividing by whatever b is. So let's see that. See if that plays out in g of x. Okay, x and then y. We'll do -2, -1, 0, 1, and 2. Okay, anything to the 0 power is 1. And then if I do 1/3 all to the first, that would just be 1/3. And then I'd have 1 over 3 squared is 1 over 9, right? And then 1 over 3 to the -1. Well, that would be, okay, so if I have a negative exponent, I interchange numerator and denominator. Oh, that's just 3. Do you think that's going to be 9? Let's see if we can verify it using the same sort of methods we did previously. So from 1 to 1/3, I multiply by 1/3. From 1/3 to 1/9, I multiply by 1/3. 3 to 1, multiply by 1/3. And 9 to 3, multiply by 1/3. Yep, works out for me. And then going backwards, I'm dividing by, oops, I want different color. As I go from 1/9 to 1/3, I am dividing by 1/3, which is multiplying by 3. 1/3 to 1, dividing by 1/3, multiplying by 3. Multiply by 3 from 1 to 3, yep. And then lastly, if I divide 3 by 1/3, that's 3 times 3, I would get 9. So that pattern seems to hold, okay? So key takeaways is that I'm going to say as x increases by 1, y multiplies by b. As x decreases by 1, y divides by b. Okay, and then also other things that you might just want to note is that b, like anything to the 0 power is 1, and then also if you have like b to the negative x, that's the same as 1 over b to the x. If you need to remember those other exponent properties, feel free to look them up too. Okay, a quick search of exponent properties can get things going for you. Okay. All right. One more thing that we need before we go on is defining the natural number e. So e is, we're going to see e come up. It is a natural number, just it is irrational, it doesn't end, but its approximate value is about 2.718, and it's called the natural number. We'll see that it pops up in certain circumstances. But for now, I just want you to be aware of it. And we're going to conclude with 2 more examples. Okay, so we want to try and construct exponential functions. Okay, so we have our first exponential function f, and we're saying that f of, okay, this is notation we've seen before. So this is our next term, okay? So we take whatever our next x value is, put it in the function, and then we would get whatever its value is by taking 2 times whatever I have now, right? So that means that another way I could write that is if I take f of x plus 1, divide that by f of x, that would be 2, right? So between successive terms, what I did up here, as I go down in my table, I'm multiplying by 2. Oh, okay, so that means that this is actually my base, b. Okay, so this is your base in disguise. And then the last thing that it tells us is that 0, when I put in 0, I get 3. So, okay, I would begin with saying, okay, y is equal to b to the x, okay? And I could have transformations of this, like I could do a, and then there'd be like another bx minus c here. I'll maybe make these capitals, and plus d, okay? Given the information here, I'm going to tell you that it's going to be of this form. Let's just make it easy on ourselves. We can make this work, okay? In this case, I know that the base of the exponent was 2, okay? And then I still need to figure out what a is. To figure out what a is, this is where I'm going to substitute this information in, okay? So I know that when x is 0, so I have 2 to the 0. I don't know what a is, but I know that y is 3, right? This is x and this is y. Okay, so then 2 to the 0 is 1. Oh, okay, so that just means that a is 3. Okay, so all this means that y is equal to 3 times 2 to the x, and this will be my function f of x, 3 times 2 to the x. Okay, let's do a similar example. Okay, one more. So let g be an exponential function, okay? And so again, we're just gonna make the simple assumption that it's gonna look like a times b to the x, okay? such that g of 1 is 7e and g of 2 is 7e squared. Okay, I don't know. This one didn't give me b right away, right? Well, here's the thing. Let's maybe just organize the information I'm given. So if I put this in a table of values like x and then y, right? When x is 1, this is saying it's 7e. And then when x is 2, it's 7e squared. Well, okay, so if I increase x by 1, what's the change here? What do I multiply by? I think it's just e, right? And whatever I multiply by is my base b. Oh, okay, so then that isn't too bad. So I know right now I have g of x is equal to a times e to the x. E is that natural number, 2.7-ish, whatever. Okay, and now how do I find a? Well, I found a previously by substituting in values, right? So let's maybe just say, okay, so if I put in this bad boy, so this is x and this is y, I have a e to the 1 is equal to 7e. Divide both sides by e. Okay, and that e to the 1 is just e. Okay, that's fine. And I get 7 is equal to, oh my goodness, there it is. So g of x would equal 7e to the x, and that's going to be my function. Okay, so again, information can be presented to you in different ways. It still will enable you to find an exponential function that fits your given criteria. And again, for now, let's just assume if we're being asked about an exponential function, let's make it easy and just say it's going to be, b to the x times an unknown constant. Okay, so try that in a couple of examples if you're ever asked to find an exponential function.